The first kind of diffusion we'll be looking at is simple diffusion. Here you can see the phospholipids in teal and yellow and the carbohydrates in purple that helps hold it together. The little blue dots represent oxygen. When simple diffusion occurs, the oxygen molecules pass through the selectively permeable plasma membranes. The oxygen molecules will move from high to low with a concentration gradient. As you can see here, the oxygen molecules move from high concentrations to low concentrations through the plasma membranes until they reach equilibrium. Simple diffusion is a kind of passive transport, which means it requires no energy from the cell. Simple diffusion is also characterized by the absence of any transport or carrier proteins to aid the diffusion process. Number 2, facilitated diffusion, osmosis. The second kind of diffusion we will be looking at is facilitated diffusion. In this case, osmosis. Here you can see the phospholipids and carbohydrates as before, but now there is a transport protein called aquaporin, and now the little blue dots represent water. When this form of osmosis occurs, water molecules travel through the aquaporins to travel through the plasma membranes. Water molecules travel through the cell membranes to move more solute molecules wherever they are. Osmosis moves from low to high on the concentration gradient. Just like simple diffusion, osmosis is a form of passive transport. This means osmosis doesn't require energy to diffuse. Number 3, active transport, sodium-potassium pump. The last kind of diffusion we will be looking at is sodium-potassium pump. Here again is the phospholipid bilayer and the carbohydrates like before. Now you can see a sodium-potassium pump moving molecules. The sodium-potassium pump is a specialized protein used to pump 3 sodium ions out of every cell for every 2 potassium ions moved into the cell. The sodium-potassium pump moves against the concentration gradient from high to low. Unlike passive transport, active transport requires energy because the molecules have to move against the concentration gradient.